Hello learners, welcome to this tutorial on Arduino Mega Board programming and simulation. So in this tutorial, I will be discussing about how to interface an electromagnetic relay with Arduino Mega Board. So a relay is nothing but an electrically controllable switch. So if we want to connect the appliances which works with more than 5 volt, something like a fan which works with the 230 volt, lamp with the 230 volt. If I want to operate some stepper motors with some 24 volt or 32 volt. So if we want to connect such appliances with a microcontroller, it is not possible directly to connect it with the microcontroller, because from the pins of your microcontroller only we can provide a logic 5 volt. In order to connect such appliances with the microcontroller, we can make use of a relay, which is going to act like an electrically controllable switch. So by the control signal will be given by your microcontroller. Depending upon the control signal, the power supply can be routed to your appliances. So the power supply can be connected externally to the relay, and the connection of your power supply with the relay will be activated by your microcontroller. So it is mainly used in industrial controls, automobiles, and for controlling various appliances. So there are 4 main types of electromagnetic relays which comes under SPST, SPDT, DPST and DPDT. So SPST is single pole, single throw. SPDT is single pole, double throw. DPST is double pole, single throw. DPDT is double pole, double throw. So we will look at these types. So here I have shown a diagram of SPST, single pole, single throw. So here this curved line indicates a coil which can be excited by passing a current through this coil. So when the coil gets excited, a magnetic field will be induced. When the magnetic field is induced, the lead connecting the A and B will get closed. So thereby, if I connect the power supply to terminal A and the appliances to terminal B, whenever the coil gets excited, the power supply will start flowing through this coil and it will reach the appliance. So such a type of connection is called as single pole, single throw. So here I can connect one device and it has one option of either open circuit or short circuit. In the second type of SPDT, we have single pole, double throw. So here also I have a coil which can be excited to produce a magnetic field, but now the power supply or the terminal C has 2 options. Either it can be connected to terminal A or it can be connected to terminal B. Before the coil gets excited, the terminal C is connected to terminal B, and terminal C is disconnected from terminal A. So this A is called as normally open terminal, B is called as normally closed terminal, because before exciting a coil, terminal B is in a short circuit, which means it is normally closed, and terminal A is normally open. So when the coil gets excited, what happens? The magnetic field will be produced, due to which the lead now which is connected to B will get connected to A. So C and A will make a connection. So thereby if I connect a power supply to terminal C, it will flow towards the terminal A, and if the device is connected to terminal A, it will get switched on. So such a connection is called as SPDT, single pole, double throw. So here also I can connect one device and it has 2 options. Either it can be connected to normally closed terminal or it can be connected to normally open terminal. Third type of relay connection is DPST. So DPST is double pole, single throw. So here it represents I can connect 2 such appliances. I have 2 poles, A1 and A2, B1 and B2. So this A1 can be interconnected with your B1, same way A2 can be connected to your B2 upon your coil excitation. So when the coil gets excited, the magnetic field is produced, Thereby the A1 gets connected to B1, same way A2 gets connected to B2. If I have connected two appliances, one to B1 and another to B2, then both the device will get switched on simultaneously when the coil gets excited. So this type of relay connection is called as double pole single throw. And the last type of relay which we are going to discuss is DPDT, double pole double throw. So here also I can connect two devices. So now the two devices has two options. So if I see C1, it can be connected to B1 or it can be connected to A1. Same way C2, it can be connected to B2 or it can be connected to A2. So when the coil is not excited, C1 is connected to B1. So this B1 is called as a normally closed terminal, whereas A1 is called as a normally open terminal. Same way, C2 is connected to B2. So B2 is a normally closed terminal and A2 is normally open terminal. So when the coil gets excited, what happens? The terminals C1 to B1 gets disconnected and it gets connected. C1 to A1 gets connected. Same way it happens to the second switch also. So both the devices which we connect to this DPDT will get either switched on or switched off depending upon the excitation of your coil. So this four types of electromagnetic relays are widely used in different applications like industrial control, automobiles and in appliances. Now in this tutorial, we are going to discuss how we are going to interface this relay with your Arduino Mega Board. So Arduino Mega Board uses Atmega 2560 microcontroller. So here I am going to use a switch connected to a pin number 11. And the relay, I can take any of this relay and I can connect it to pin number 13. So usually the coil, one end of the coil will go to the microcontroller port line, pin number 13. Other end will go to a supply. So the supply will be coming. So for example, here this end it will be connected to supply and the other end of the coil will be connected to pin number 13 of your microcontroller. Then we connect a power supply to the relay. So the power supply can be connected to terminal A and some LED bulb or light bulb which operates at higher voltage, 12 volt, can be connected to terminal B. So whenever the coil gets excited, so whenever the pin number 13 goes to low, the coil will get excited. When the coil gets excited, there will be a short circuit between A and B. So thereby the supply will be routed towards your bulb, thereby the bulb will start glowing. So that is how we are going to write a program and we are going to do the demonstration of this switch controlled relay interface with Arduino Mega Board. So now let us move on to the programming part. So first let me start with Proteus. I'm going to create a new project, select a location where we are going to save the project, and I'm going to give a name for this project. I will put it as relay. So two things we have done here. One is select the location where we are going to store the project and the project name we have defined, relay.pdsprj. Next, first I am going to use a default schematic where we are going to build our circuit. So I am going to select the default schematic. Next, we are not going to do any PCB layout, so I am going to leave it as it is. Next, and also I am not going to use any firmware, so I leave it as it is. Press next. So when I do that, you can see only the schematic is selected, layout and firmware are not selected. So press finish. It will open this schematic window where we are going to build our circuit. So in order to build the circuit, we need to first select the components. So selecting the components, I go to pick device. So here I type Arduino. So here you can see the Arduino Mega Board 2560 board. Double click on this, it will get added to your list. Same way I require a relay. I type relay. So here I have a relay. You can see this is a single pole double throw relay. So I am going to select this relay, add it into our list. Next I require a lamp. So I type lamp. So here I take some animated light bulb which operates at 12 volt. So double click on it, it will get added. So these are the components right now I require for this project. So I have selected all the components. Once I have done, I press OK. So now the components have been selected. Now we are ready to build our circuit. So first let me select the Arduino Mega Board, place it onto your schematic. And one more thing, we also require a switch. So we have to get a switch, go to pick device. So I am going to take a switch, add it to our project. So now we have to decide where we are going to connect our relay and where we are going to connect our switch. So I'm going to connect the relay to pin number 30 and I'm going to connect the switch to pin number 7. So first let me take the relay. So I will put it here. So as I said, the coil voltage will be given by an external supply, only the ground will be given by your microcontroller. So now let me go to the terminals mode, select the power and I will place it here and I will connect this power to one end of the coil. Other end of the coil I am going to connect it to pin number 30. So supply comes to the coil through the external power supply, so and it will get grounded in your microcontroller pin number 30. So now I am going to select a lamp. I can rotate this lamp and place it in my schematic. It's a 12 volt bulb. One end of the bulb I am going to connect it to normally open terminal. This is a normally open terminal. This is a normally closed terminal. So now I have to give power supply to this lead. So in order to give a power supply, on the left side you can go and find generator mode. In generator mode you can find different types of voltages which you can generate. DC voltage, sine wave, pulse, exponential. So like that we have different formats of voltages which we can generate. For this application I am going to use DC voltage source. So I am going to place my DC voltage source here and connect this DC voltage to the relay coil. So now I have to define what is the voltage, because our bulb requires a 12 volt voltage. So I want to select the 12 volt. So in order to do that, right click on this power supply terminal, edit properties. So here DC voltage is selected. In voltage I will put it as 12 volts. Press OK. Then other end of the bulb I need to ground it. I go to terminals mode, select ground, place it onto the schematic and connect the ground to your bulb. So now one important thing here you have to notice, the relay is a 12 volt relay. So the coil voltage should be 12 volt, then only it will get excited, thereby the normally closed terminal can get disconnected and it can get connected to the normally open terminal. But from our microcontroller we can have only 5 volt as a supply. So thereby I need to change the coil's excitation voltage. So in order to do that, right click on this relay, edit properties. Here coil voltage I am going to change it to 5 volt. So this is the coil excitation voltage. Press OK. So now the coil will get excited. Whenever the power supply flows through this coil, the coil will get excited. Thereby the power supply will be connected to your bulb. Thereby it flows. So now I am going to connect a switch to pin number 7. So again I go to component mode, press switch, place it onto our schematic. So I connect one end of this switch to pin number 7. Other end I am going to connect it to supply. Go to terminals mode, power, place it onto your circuit. So now what happens? This pin number 7 by default it will be at high impedance. So whenever I press the switch, it will go from high impedance to 5 volt. So that is not desirable. So in order to avoid that, I am going to use a resistor and connect it to ground. So again I go to component mode. Again I go to component mode, pick device. I am going to select a resistor. So add a resistor to the selection, press OK. So now I am going to place this resistor in my schematic and I am going to connect it to this terminal. And other end of the resistor I am going to ground it. I am going to use a ground to ground this resistor. So now what happens? The pin number 7 by default it will be at ground. Whenever I close the switch, the pin number 7 will come to high. So when the pin number 7 comes to high, then I am going to make pin number 13 to go to low. In that case, the relay will get activated, thereby the power supply can be routed to your lamp, thereby the lamp will glow. So this completes the hardware part of our relay interfacing with Arduino Mega Board. So let us save this project and then we will move on to the programming part. So two things you have to remember. We are going to connect the relay onto pin number 13 and the relay will get activated if I give a logic 0 to pin number 13. And the second thing is we are going to connect a switch to pin number 7. So whenever I press a switch, in 7 we try to get a logic high. So now we will move on to Arduino to write a program. So let me open Arduino. First thing we have to do is we have to go and select the board. We have to select the board Arduino Mega and then processor will be 2560. And if a hardware Arduino board is connected, you have to configure the COM port also. Now first I am going to define two variables, int switch equal to 7. Next one is int relay equal to 13. So two pins where we are going to connect both relay as well as switch. So switch is connected to pin number 7 and relay is connected to pin number 13. So now in the void setup function which runs for only once, here we have to do the configuration part. So in order to do the configuration, I am going to use pin mode . Pin mode. So I am going to first configure my switch as a input pin. So switch as a input. Second thing is we need to configure the relay as a output pin. So again I define pin mode relay comma output. This completes our configuration part. So we have declared switch as an input pin and relay as an output pin. So now we go to the void loop function where we are going to write the logic. So in the logic part, first thing what we need to do is we need to check whether our switch is pressed. If the switch is pressed, I need to activate the relay. So in the loop part, I am going to define a variable button state equal to digital read of switch. So I am going to read the switch status and it will get assigned to button state. So now we need to check the button state. What is the status? Whether it is pressed or not. So I am going to use a if statement. If button state, for checking equality we need to put double equal to whether it is high. If that is so, we need to execute a set of code. So here I am going to put, we need to, when the button is pressed, it will be in high state. So we need to activate the relay. For activating the relay, we write digital write relay, which will activate your relay. Logic low will activate your relay. So I type low. Then we need to retain this value for some time, then only we can visualize the output. So I put a delay function here, delay of some 2 seconds. So let 2 seconds, it is going to be in on. 2000 means it is indicated in a millisecond, 2000 millisecond. So if the button state is not high, in that case I am going to put else part. In else part I am going to deactivate my relay. Digital write of relay, comma high. High will deactivate your relay. And I am going to retain this value for a short duration. So delay of some 500 milliseconds. So that completes our program. So here what we do in our void loop statement, we read the status of the switch and load it onto a variable button state. And then I am going to check whether the button state is high. If it is high, I am going to send load to the relay, which means it will excite the coil. When this coil is excited, the power supply will be routed to your lamp. If the button state is low, in that case I am going to send high to relay, which means it will deactivate the coil and the power supply will be cut off. It will not reach your lamp. Thereby the lamp will be in off state. So now we are ready with the code. We need to compile it. So for before compiling, let me save the program. So I will put it as relay.c. Then do compilation. It shows an error. So it shows an error. So if you look at the error, it shows unqualified ID before switch. Here we have used a variable named switch. Usually we will try to use the switch in the switch case statement. So this we can't use it as a variable name. So we will try to change the name of this because already it is a keyword for which is used for your switch case statement. So I am going to put it as switch 1. And here also let me define it as pin mode also. I change it to switch 1. Same way in digital read also I am going to change it to switch 1. So now it is not a keyword. So now let us compile and see. So now it got compiled and there is no errors. So now let us convert this high level language program to a executable file, hexadecimal file. So in order to do that, go to sketch, export compiled binary. So when I do that, a hexadecimal file will be generated in the folder. So let us go and see that folder. So here I have created the hexadecimal file. So we can open this hexadecimal file in a notepad, and this is the hexadecimal file which we are going to import into the program memory of your Atmega 2560 microcontroller. So now we are ready with our code and our circuit is also ready. So now we have to import this hexadecimal file into our circuit. So let me go to Proteus, right click on this Proteus microcontroller, edit properties, select the program file. So go to the location relay.c. In that I am going to select the hexadecimal file, which is equivalent to putting your code into the program memory of your microcontroller. Once this is done, press OK. So now we have imported our code to a microcontroller. Let us save the file. Let us execute the program and see whether it is working properly or not. So when I press it, right now the bulb is in off state. So if I close the switch, you can see now the bulb is glowing. So you can see when I press the switch, this pin is in logic high. Red indicates logic high. And you can see the pin number 13 is at logic low. So the logic low excites the coil, thereby the power supply 12 volt gets connected to your bulb, thereby the bulb glows. So if I remove, you can see right now the connection is with the normally open terminal. So when I remove the switch, you can see it come back to the normally closed terminal. So the light gets deactivated. Again, when I press the switch, you can see the bulb starts glowing. So this is how we can connect the appliances which work with higher voltages to your microcontroller. So now the relay is going to act like a electrically controllable switch. So in this tutorial, we discussed about how to interface an electromagnetic relay with your Arduino Mega Board. Thanks for watching. Please subscribe for more technical learning. Thank you.